Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Muhammad Muhammad, and today we'll be starting a new chapter, Chapter 2, Lesson 1, Frequency Distributions and Their Graphs. So our objectives for this lesson will be how to construct a frequency distribution including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries, how to construct frequency histograms, frequency polygons, relative frequency histograms, and ogives. And then the frequency distribution. So it's basically like a table that shows classes or intervals of data with a count of the number of entries in each class. The frequency, which is labeled as f, of a class is the number of data entries in the class. So as you can see here, we have the classes and we have the frequency over here. So in class 1 to 5, the frequency was 5, 6 to 10, 8, 11 to 15, 6, 16 to 20, 8, 21 to 25, 5, 26 to 30, 4. And then each class has a lower limit, which is the least number that can belong to the class, and an upper class limit, which is the greatest number that can belong to the class. So as you can see, 1, 6, 11, 16, 21, 26 are the lower class limits, and then 5, 10, 15, 20, 25, and 30 are the upper class limits. And then the class width is the distance between the lower or upper limits of consecutive classes. The difference between the maximum and minimum data entries is called the range. So this is the class width. So 6 minus 1 equals to 5. And then over here, constructing a frequency distribution. Decide on the number of classes, usually between 5 and 20. Otherwise, it may be difficult to detect any patterns. There will be way too many numbers or way too little numbers. And then find the class width, so determine the range of data, divide the range by the number of classes, and then round up to the next convenient number. And then find the class limits. You can use the minimum data entry and the lower limit of the first class. Find the remaining lower limits, add the class width to the lower limit of the preceding class. Find the upper limit of the first class. Remember that classes cannot overlap. Find the remaining upper class limits. And then make a tally mark for each data entry in the row of the appropriate class. Count the tally marks to find the total frequency of f for each class. And an example of constructing a frequency distribution would be a dataset lists the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. They construct a frequency distribution that has 7 classes. As you can see, we have numbers 200, 239, 155, 252, 384, and so on. And then first, the number of classes is equal to 7, which is given. And then find the class width, well, we'll round up to 36. So we use 155 as the minimum value. As you can see, there is no number lower than 155 here. And then add the first lower limit, and then add the class width of 36 to get the lower limit of the next class. So you do 155 plus 36, which equals to 191, and so on. And then find the remaining lower limits using that formula. And then the upper limit of the first class is 190, one less than the lowest limit of the second class. Add the class width of the 36 to get the upper limit of the next class. So 190 plus 36 equals to 226, which will be the upper limit for the 191 class. And then find the remaining upper limits. And then make a tally mark for each data entry in a row of the appropriate class. Count the tally marks to find the total frequency, f, for each class. So as you can see here, the frequency is the number of adults. And then we check the sum of the frequencies, which equals the number in the sample. So as you can see, we got 30. And then these are the expenses. And then determining the midpoint of a class would be the lower class limit plus the upper class limit divided that by 2. And then determining the relative frequency. Relative frequency of a class, portion or percentage of the data that falls into a particular class. And then the formula for relative frequency would be the class frequency divided by the sample size, and then variables that would be written as f divided by n. And that always know that n is always equal to the total of the frequencies. And then cumulative frequency of a class, the sum of the frequency for that class and all previous classes. And then the cumulative frequency of the last class is equal to the sample size n. And then finding midpoints, relatives, and cumulative frequencies. And an example would be using the frequency distribution in the previous example. Find the midpoint, relative frequency, and cumulative frequency of each class. Describe any patterns. So the midpoints, relative frequencies, and cumulative frequencies of the first 5 classes are calculated as follows. So as you can see, we got the frequency 3, 2, 5, 6, and 7. And then we have the midpoint where he took the lower class limit plus the upper limit, divide that by 2, which equals to 172.5, and so on. And for the relative frequency, f over n, that would be, he did 3 divided by 30, and then 2 divided by 30, and so on. And then the cumulative frequency would be 3, and then 3 plus 2, and then 5 plus 5, and 10 plus 6, and then so on. And then the remaining midpoints, relative frequencies, and cumulative frequencies are shown in the expanded frequency distribution below. And there are several patterns in the dataset. For instance, the most common range for the expenses is $299 to $334. Also, about half the expenses are less than $299. And then now we're going to move on to graphs of frequency distributions. So our frequency histogram is basically a bar graph that represents the frequency distribution. The horizontal scale is the quantitative and measures the data values, and then the vertical scale measures the frequencies of the classes. So, and then the consecutive bars must touch, so you can't have a gap between them. And then class boundaries, because consecutive bars of a histogram must touch, bars must begin and end at class boundaries instead of class limits. The numbers that separate classes without forming gaps between them. So draw a frequency histogram for the frequency distribution in the previous example. Describe any patterns. So we're going to use these numbers and make it into a histogram. And then first we have to find the class boundaries, and then the distance from the upper limit of the first class to the lower limit of the second class, which is 191 minus 190 equals to 1. So half this distance is equal to 0.5. So we're going to do first class lower boundary is equal to 155 minus 0.5, which equals to 154.5. First class upper boundary is equal to 190 plus 0.5, which equals to 190.5. And then you can mark the horizontal scale at either at the midpoints or at the class boundaries. Both histograms are shown below. So as you can see, we have the two histograms. Over here we have a broken axis. And then here are the frequencies, 3, 2, 5, 6, 7. And these are the limits. And then over here you can see that the 2/3 of the adults are paying more than $262.50 for out-of-pocket prescription medicine expenses. As you can see over here, the graph says over here. And then a graph of frequency distributions, a frequency polygon, a line graph that emphasizes the continuous change in frequencies. As you can see, there's an example. So draw a frequency polygon for the frequency distribution in the previous example. Describe any patterns. Again, we're going to use the same numbers and create a polygon, a frequency polygon. So to construct the frequency polygon, use the same horizontal and vertical scales that were used in the histogram labeled with class midpoints. So over here we still have frequency, and then we have the expenses, and the frequency is equal to like the number of adults, and then expenses dollars. So the graph should begin and end on the horizontal axis. So extend on the left side to one class width before the first class midpoint, and extend the right side to one class width after the last class midpoint. And then you can check your answers using your calculator, like your TI-84 Plus, which many of you should have by now. It's a graphing calculator. And you can see that the frequency of adults increases up to an expense of $316.50, and then the frequency decreases. And then the graphs of frequency distributions, relative frequency histogram, has the same shape and the same horizontal scale as the corresponding frequency histogram. The vertical scale measures the relative frequencies, not the frequencies. So then an example of constructing a relative frequency histogram would be construct a relative frequency histogram for the second example. So from this graph you can quickly see that 0.2 or 20% of the adults have expenses between $262.50 and $298.50. As you can see, the difference between this graph and the regular frequency histogram is that the numbers are not as exact and are not as precise as before. And graphs of frequency distributions, cumulative frequency graph or OGIV. So a line graph that displays the cumulative frequency of each class at its upper class boundary. The upper boundaries are marked on the horizontal axis. The cumulative frequencies are marked on the vertical axis. So constructing an OGIV, construct a frequency distribution that includes cumulative frequencies as one of the columns. Specify the horizontal and vertical scales. The horizontal scale consists of the upper class boundaries, and the vertical scale measures the cumulative frequencies. Plot points that represent the upper class boundaries and their corresponding cumulative frequencies. And then constructing an OGIV, connect the points in order from left to right, and then the graph should start at the lower boundary of the first class, which the cumulative frequency is 0, and should end at the upper boundary of the last class, where the cumulative frequency is equal to the sample size. An example of that will be using the same numbers we had before and constructing an OGIV. So from the OGIV, you can see that 10 adults had expenses of $262.50 or less. Also, the greatest increase in cumulative frequency occurs between $298.50 and $334.50. As you can see, the graph exponentially grows as we go down, explaining this answer, $298 and $334. And in technology to construct histograms, we're going to use an example from here. So we're going to use technology to construct a histogram for the frequency distribution in the second example. So over here we can see we have to use a TI-84 Plus calculator. It's your graphing calculator. So we're going to enter the midpoints in L1 and then enter the frequencies in L2, and then turn on plot 1, highlight the histogram, and then we're going to do L1, L2, and then so on and so forth. So using the instructions for a TI-84 Plus shown, you can draw a histogram similar to the one shown below. As you can see, the histograms are all touching, and it looks just like a histogram should. And another example would be after passing trace, the midpoint and the frequency of the first class are displayed and are shown in the figure. So use the bar and the left arrow keys to move through each bar. So as you can see, the arrow keys on your calculator, you can use those to move around the graph. And then histograms made using Minitab and Excel are shown below. As you can see, Excel and Minitab are both great examples of creating a histogram. I recommend Excel as it's easier, but yeah. And an example as well for technologies using StatCrunch. Over here we can see, and that's it. So basically, just to get a quick overview of the lesson, let's go back all the way up here. So we learned about the classes, or also called intervals, and the frequencies. And we learned lower class limits and upper class limits. And then we learned class width and the range. And then we learned how to construct a frequency distribution. And after that we got a few examples of that. And then we continued on. And over here we learned how the formula for a midpoint of a class, which was the lower class limit plus the upper class limit, divided that by 2. And then for relative frequency, it is class frequency divided by sample size, which is basically f over n. And then the n is always equal to all the frequencies combined. And then we got a few examples of midpoints, relative, and cumulative frequencies, as you can see. And then we learned frequency histograms, and then we learned that the y-axis and x-axis, the frequency and data values, and how the bars always must touch. And then we learned about class boundaries, and then we had a few examples. And then we learned about a frequency polygon, which is a line graph that emphasizes the continuous change in frequencies. And after that, we had a few examples. We learned how to use it on a TI-84 Plus, and we did a few more examples. We learned how to use a cumulative frequency graph, or also known as the OGIV, and we learned how to construct it, and then we got an example of that. And then we learned how to put that into a TI-84 Plus, and then we learned how to put on Minitab, Excel, and StatCrunch. So this concludes lesson 2.1. Jazakallahu khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.